Hello everyone. So in this lesson we're going to take a look at a very simple project on how to fill up a glass with some kind of a liquid, and then we drop like a box in it. In our case we're going to assume that it's an ice cube, and then also have that ice cube sort of float on top. So it allows us to see how to mix flip with rigid bodies and then also have them interact with each other. Okay, so to get started, I'm going to copy a few of these things. So what I have is I have this sphere which is my emitter. So I'm going to take this, and then I have my glass. Okay, because this is pretty simple, right? So this is just a tube, and I used a polyfill to fill up the base. So you just select those many edges and you use a polyfill, and then I use a poly extrude to give it some thickness, and then a match size to put it on top, and then just rotate it a bit. Okay, because it just looks like if it's straight it will still fill up, but it looks better if it's kind of slightly rotated. And then I put it into a group because after the simulation is done we would like to sort of separate everything out. So it's a good idea to put the whole thing into a group. Okay, so what I'm going to do is I'm going to select all of this, and then this is the box, which is nothing, it's just a box. Okay, so the box is going to sort of fall into the glass. Okay, so I'm going to select all of this and copy it. So I'll do like Control C, Control V. I'll also come into the simulation and I'm going to reset this so that it frees up RAM, so I don't have to worry about that. So to get started, I just have this, which is my sphere, and then I had done a clip on it, it's not needed anymore, so it's just a full sphere. And then you turn it into a flip source. So I'm just going to delete this because it's connecting to the previous one. Yeah, so what we have is just, it makes a VDB and it generates particles inside it. Okay, so the voxel size is currently connected to the particle separation. Okay, that's pretty much it. What I'll also do is, if you wanted to, if you don't want like a very regular stream, you can kind of animate the jitter seed. Okay, so what I can do is I can just put like an at frame in there. And what this will do is, like on a per frame basis, the position of the points will just randomize. So this is done. So we'll bring in these guys later. For now, I'll just set up the basic simulation. So what I'm going to do is just take this. I'll take a DOP network and we'll just call it liquid. Let's also name these guys. So this is out glass and this is out box. Fine. Or let's call it out ice cube. So to get started, I'm just going to connect this in. Let's come in here, and we'll need two things. So I'll need a flip object. I'm just going to remove, like it has an inbuilt particle generation thing, so I'm just going to get rid of that. And then we need the flip solver. So just take this. You can connect these two, and then we need a gravity. So just put in a gravity here. We will in the end modify the gravity as well, but for now, just to do the basic setup, we'll do this. What I also want to do with the flip solver is come into volume motion, and I'm just going to modify this. So is my glass above the ground? I think it should be. Yeah, it's almost above the ground. Okay, hold on. Let's just take this and put it, yeah, above the ground. Okay, so I can come in here to this guy, come to the flip solver, come to volume motion, we'll just adjust this. So I'm going to take the Y, do copy parameter, paste relative reference, divided by 2. So this box is like, touching the ground, and I'll make it like 2 by 5 by 2 because it's just a glass, right? Like we just have that. Let's make it slightly bigger. And now we can bring in our fluid. So just type in source, and you'll get something called volume source. Okay, so just take the volume source. We'll just call it fluid ball, and this will be set to source flip, and we'll pick up first context geometry, and I'll plug this in. So we should see this. Okay, now I think we can get it smaller still. So because the glass is just going to be about that much, right? So there's no need to waste space. Okay, like it'll be easier to do it with this. And now what we also want to do is we want to connect the particle separation, which is in the flip object, to the particles, that are being generated. So I can right click here, copy parameter, come up to the flip source and connect it to the voxel size. So now whatever value is being set inside is what will be set out here. And then I can just take this to, hold on, I think my point type is on pixels. Yeah, I'll just change this to points. Yeah, okay. Can we make it bigger? Okay, and then make this 0.05. That should be good enough for a start, and we'll do close boundaries. So what this should do is, if you've done everything right, is we'll just get like a basic simulation. So there you go. Okay, so this is fine. Now let's bring in the glass. Okay, so there are a couple of ways to do collisions, but what I realized was like you can also set up like a volume based collision here, like a VDB based collision. But I found like the static object is a bit more reliable. Okay, so I'm just going to take like a static object, and we will pick up the, click here, we come to out glass, and then we'll merge these two together. Okay, and now what you want to do is come in here. I'm going to turn off display geometry, come to collisions, and we'll set this to use volume collisions and turn on volume guide. And then I can just take these uniform divisions and make it about 60. Okay. Now, if you don't want it to calculate here, you also have an option to pick up a proxy volume. Okay, so I can calculate a VDB beforehand, and then just feed that in here. Okay, because like if you have an animated geometry that you're using for collisions and it's going to calculate this on a per frame basis, it will be a problem. Okay, so what you can do is like you can cache it out to a drive and then just load that file cache over here. Okay, so those things are also possible. In our case, we just want like a static glass, so it's fine. And then if I press play, I'll just turn this off and it should work. Okay, so if I press play here, I should get, okay, now this is causing issues, it's not filling up. All right, so one of the issues that happens is if your collision geometry is too thin, then it just, it sort of like refuses to fill up. So what you can do is, for the collision geometry, you can use something slightly thicker, and then for final render, you can use like your actual geometry. Okay, or then you have to sort of like crank up the sub steps a fair bit for it to start working. So it's like a compromise that you have to make. Okay, so in this case, what I'll do is I'll just take the poly extrude and make it about 0.2. Okay, which is a little too thick. Let's try 0.16 and let's see if this makes a difference. So now this starts to fill up. Okay, so even making like that much of a change in the thickness of your geometry makes a fair bit of difference. So now what I can do is I can just take I'm going to take the activation in the fluid ball, and I'm going to make it about $FF less than 30. So after 30 frames, it will stop. Okay, so if I press play now, so the glass will sort of fill up till about 30 frames and then it will stop. Okay, now the first thing we want to do is we want to control like how much this is splashing. So what we can do is we can add a drag to this based on the speed. Okay, so the first thing I want to do is I just want to visualize the speed. Okay, so I'm going to come into the flip object, and in the guides, you'll find particles, and this is default, it is kept to speed. Okay, you can say detect range, but this is fine. So let's do one thing. This is blue, and this is, let's make it like red or something. Yeah, if the color doesn't show up from here, just open up your ramp and click there, like it will show up from here. So I'll just make it, like this. Okay, so we'll turn off detect range. Okay, so the fast moving stuff is red, and then it slows down, it's blue. Okay, so what we want to do is when it slows down, we want to give it a drag. Okay, so the fast moving stuff remains fast, but then the minute it starts to slow down, it really slows down a lot. So I can just, this is a useful way to just visualize how your speed is working. Okay, so there you go. So what I can do is over here, we can just add like a pop force. Okay, so where you see like the second input is called particle velocity. Okay, like the name comes at the bottom, okay, where you can see like it says flip solver 1 particle velocity input 2. Okay, like that's what we want. Okay, so just take a pop drag, and I'm going to plug this in, and I'm going to use an expression. So just click here. So it'll just bring up the air resist, because I think this is called air resist. So I'm going to delete this. I'm going to take the drag up to about 2.5, and I'm going to use a ramp. Okay, but for the ramp, I'm going to create a speed attribute. Okay, so I'll just call it float speed is equal to the length of velocity is speed. Okay, so length of at v. Velocity is already there, so we don't have to worry about that. And then here, I'm just going to create a ramp. So just take ch ramp, and I'll call it speed drag, and it'll use speed. So you don't need to do an add speed, because this is just a, when you type in float speed, it's just a, it's not generating a full attribute, it's just generating a float value just for this. So it's not going to be stored anywhere. Okay, so you can just type in the name and that will be enough. And then just click here and it'll generate a ramp for you. So what we want is based on this, like this is the area where we want drag. Okay, so I'm just going to come in here. And this is multiply equal to. So whatever we're doing here will multiply with a value of 2.5. So I can just take this, I'll keep two values here and then just bring this down. And what this should do is if I press play, so you'll see like it splashes a lot less now. So the minute it starts to slow down, it applies like a fair bit of drag to it. So like what was happening before where it was just splashing around. See, now it can settle down a lot faster. So if we look at the simulation without the drag, we can see like how much water sort of splashes out. And like how long it takes for the liquid to sort of settle down. Right, so it's sort of like it's still sort of splashing almost till like frame 100 or even like 120. And then if we connect the drag in there, and I'll just sort of spread it out a bit more. I'll take it up to around 5. And if we play now, so it splashes a lot less, plus all, and also this starts to, settle down a lot faster. Okay, like we can take this up a little higher. Let's take it up to 8 just to see if, we can really see the effect of this. So you can use speed, you can also use age. Okay, like if you wanted to settle down based on age, you will have to turn it on. So there you go. See now you can see like it's almost stable, like it's barely moving now. So you can sort of like, decide how much you want. So if you want to do age, you'll have to come into the flip solver, come to particle motion, you'll have to turn on age particles. Okay, so when you turn it on, then you'll be able to use the age attribute. Otherwise it doesn't generate an age attribute, because fluid isn't supposed to disappear. So it just sort of, remains there for as long as it can. Okay, so this is fine. Let's do one thing. Let's take the fluid ball and we'll make it about 25. So it doesn't, like, I think it's like filling up way too much, so it's splashing. Yeah, I think this is good. And let's also up the resolution a little bit. So let's make the 0.03. Okay, so now that our fluid is done, okay, let's bring in the box that we're going to drop into this. See, so there you go. So it doesn't splash as much and also starts to settle down, fairly quickly. Okay, now in order to bring in the box, what we'll do is I'm just going to take this out, and we'll take an RBD object, and we want to pick up the box. So it will be outbox. Is it called outbox? Hold on a second. Oh, it's called out ice cube. Okay, hold on a second. Yeah. So pick up out ice cube, and then we connect it to the rigid body solver. So that comes in here, and we can merge these two together. So we just do a merge here. So we merge these two, and those two things go into gravity, and we say the effector relationship is mutual. Now this is fine, but we're going to have a problem, which is the box will start falling, pretty much immediately, which is not what we want. So what we want is maybe after around frame 70 is when the box should drop. So how do we do that, right? So what we're going to do is I'm going to take out the gravity, and I'll put the gravity here with the rigid body solver. So now only the box is going to fall. Okay, but we also want a gravity for our fluid. So I'm going to take a pop force and use that as gravity. So I'll just come in here and plug that in, and this will be called gravity, or we'll call it fluid gravity. And this will make it minus 9 point. Now, what we want to do with this gravity is I'll keep it to 0 for now. And if we press play, so now what will happen is we'll get this guy falling, we'll have our liquid falling, but we won't have the box falling. Yeah, so this is fine. Okay. With this, what we want to do is I just want to take this and set this, because we're going to animate it, right? So set the default operation to always. Otherwise, what will happen is it will just read the value at frame 1 and then not read anything. Okay. So then close this, and then let's come to about, let's try 70. Okay, and we'll do alt click and come forward 1 frame and make it minus 9.8. So at frame 73, the box will drop. Okay, so if we press play now, yeah, you get this thing filling up. Okay, but the problem with that is I want the box to actually, like, the box is dropped to the ground, dropped like straight down to the bottom of the glass. We don't want that, right? We want the box to sort of float. Okay, so that is actually pretty simple. All you have to do is come into the flip solver, come into volume motion and solver, and you'll find something called feedback scale, and just make that 1. Okay, so what this will do is it will make the box interact with the fluid. So the higher you keep it, the more the box will sort of interact. If it's too high and if the box is too light, it won't, sync at all. So, but this is how you kind of, mix those two things together. Let's also do one more thing with the drag, which is I just want it to be, yeah, let's keep this a little higher like that. So maybe like that huge splash that we're getting, we might not get that. Yeah, that's not bad, but hold on. Okay, now we're getting somewhere that feels controllable. Okay, let's do this. Yeah, that initial splash was feeling like a bit too much. Okay, yeah, I think this is better. Let's also increase the activation a bit more. So let's take it up to 30. So it can fill up a bit more. But yeah, just play around with the drag till you get something that you're happy with. Yeah, so the rest you can sort of tweak, based on what you want. Let's lower the point size a bit. Okay, and let's increase this to 0.02. All right, so there you go. So you have a nice refreshing drink with an ice cube. So I just modified the drag curve a little bit, so it looks like this now. But yeah, you can sort of just play around with it till you get the result that you want and doesn't splash around way too much. Okay, and then the advantage of this is that because we put all of these into their own groups, like the box is in a group and the glass is also in a group. So when you come out here and you just take a blast, you can separate all of these. So I can just come in here and we can pick up the stream fluid ball and I can set it to points and to delete non-selected. So there you go. So you just have the particles. And then the same way I can just, separate out the, we can pick up the glass. Okay, so I can do like primitives, delete non-selected. There you go. So this is just the glass. And what I can do is I can actually like make this thinner now. So I can take a blast here because I'd made groups out of this. So I can just take the extrude back and delete nonsense. So that's the inside part. See, so if I can check here, see, so we just have like, you know, the inside stuff filling, and I can give this another poly extrude and just make it, you know, the size that I want. So I can just take this and make it, you know, about that much. Yeah, just reverse it because, yeah, so now what will happen is if we merge these two together, like I kind of calculated the speed here as well. So I can just take this much, do Control C, Control V. So what I have is I'm just calculating the speed, you know, so I'm doing speed length at length V, and that's the, it's using the speed for coloring. So if I plug this in and I merge these two together, see, so now you have, you know, like a proper thin glass. And then we can also bring in the ice cube, which was just, it's called box. Yeah. Yeah. So what I had done was I just gave them like alpha values. So I can just take this and do Control C, Control V, and, you know. So yeah, so this has, the glass has an alpha of like 0.25 and everything else is an alpha of 1. So this is 1, and so if I press W, it still splashes a bit, but yeah, you can sort of like, you know, at least you know the basics now of what you want to do. All right, so that's pretty much it. So this is how you can have like liquid falling in a glass and then have it interact with like a rigid body object.